This question only requires answers, but we should show sufficient working so that somebody could, understand what's going on if they needed to. So I might not be like completely rigorous, but I'm going to try and, talk through how I would do it. Right, we've got this ABC denotes a three-digit number with digits A, B, and C. It's got this little line above it. And then we're asked to write down all three-digit multiples of 3, which only contain digits 1, 2, and 3, and digits can be repeated. So what that's going to mean is that for something to be a multiple of 3, it means the sum of the digits has to also be a multiple of 3. So A plus B plus C must equal 3 or 6 or 9 or 12 or so on. So let's look at the different cases. So if A plus B plus C is 3, and I think we have to, yeah, we're not allowed to have 0. So for this, it's got to be the number 1, 1, 1. That's the only one. Right, what if they could equal 6? So now I've got 2, 2, 2 straight away, but I could also have 1, 2, 3. And then all the different arrangements of 1, 2, 3. In fact, there are 3 factorial or 6 arrangements of this as you order them. 3 options for the first number, then 2, then 1, because I'm just looking at the specific case 1, 2, 3. We could also just write them down systematically, and the question does ask us to write them down. So we're going to have to write down all 6. That's the one starting with 1, and then we've got 2, 1, 3, 2, 3, 1, and 3, 1, 2, and 3, 2, 1. Okay, there we have it. So 7 there. And then the only other option is going to be A plus B plus C is 9. Okay, we can't go any bigger because the largest the numbers that could be would be 3. So 3, 3, 3 would give us our answer. And those, therefore, are the answers to part A. Okay, we've got these 6, then we've got these other 3, so there's 9 possibilities. Just going to write that down even though it didn't ask for it. In part B, remember this is actually probably building us up to the last part. In part B1, it says write down the values of B for which 9b to the B is less than 1000. 9b to the B less than 1000. Well, that means it's less than or equal to 999. So B to the B is going to be less than or equal to 111. And we've only got, there's only a certain number that we have to try. Remember, B is still like this digit. Essentially, it's not going to be as you can't be 0. You can't have 0 to the power of 0. Actually, that's not defined. So it's going to be say 1 to the 1, which is okay, or 2 to the 2, which is okay. 3 to the 3, 3 cubed is 27. That's okay. That's less than 111. 4 to the 4. 4 to the 4 is 4 squared squared, which is 16 squared, which is actually 256. Work that in whatever way you want. That one's not okay. So B is equal to 1, 2, or 3. Okay, those are answers for part B. Or at least it was part 1 of that question. So here's the main events. Let A, B, and C be non-zero digits. Find all three-digit numbers A, B, C which satisfy this equation. Now, we've already, this thing here is got to be less than or equal to 999. So we can already see the relation with, this is actually takes a bit of time. When I did it, I don't know, I kind of jumped into it and then I had to sort of take a step back and think, how do the earlier parts relate? So B can only equal 1, 2, or 3 from before, from B part 1. Because as soon as B is 4, you're going to get a number here which is too big. So I need to sort of take a look and see about the other ones. We also need that 3c to the c is going to be less than or equal to 999. And therefore c to the c is going to be less than or equal to 333. Okay, well actually there seems to be less restrictions here. So let me take so now 4 is okay, but I think 5 is going to be too big. 5 to the 5 is definitely bigger than 333. So c can equal 1, 2, 3, or 4. Now let's do the same for a. We also need that 6a to the a is less than or equal to 999. So 2a to the a is going to be less than 333. A to the a is therefore going to be less than or equal to, if I need to find half of this, 166.5. So we're okay again with 1, 2, and 3, but not 4. You can sort of see some similarities with part A going on here, where we're only allowed to use digits 1, 2, and 3. But now I've got B can be 1, 2, or 3, A can be 1, 2, or 3, but C could be 1, 2, 3, or 4. I'm just going to investigate this 4. And I've got to be honest, when I did this question, I didn't investigate it at this point. I kind of went through some calculations and then at the end, kind of did it in a not so quite eloquent way to what I'm going to show you now. So if C is equal to 4, then we're going to get 3c to the c is going to equal 3 times 4 to the 4, which is 3 times 256, which is actually 750 plus 18, so 768. So we're necessarily going to get A, B, C is greater or equal to this 768, because remember, this ABC is constructed from this sum, and we've already just said this is the case when C is 4. So then we would require A to be well, greater or equal to 7, which is not possible because I've just shown above that it can only be 1, 2, or 3. So no solutions. Like I don't need to do any more. I don't need to think about multiples of 3 that involve a 4 because it's just not possible. No solutions. C equals 4. What we're left with actually is all 3-digit numbers that can involve 1, 2, and 3, which satisfy this equation. And remember, in part A, we actually found all 3-digit multiples of 3, all 9 of them. So I can use that and then just check each one individually. And we're going to have to do that. So check each of these. On whether, I've forgotten the equation, 3c to the c plus 6a to the a plus 9b to the b is equal to a, b, c, this number here. Okay, so let's just go by it one by one. Right, for so actually, sorry, I'm going to line it up. I've got my A, B, C here. First one's going to be 1, 1, 1. And then I've got my 3C to the C plus 6a to the A plus 9b to the B. For 1, 1, 1, it's going to be 3 times 1 to the 1. So that's just 1, 3 plus 6. That's also 1 plus 9. And they're clearly not going to be equal. So I can cross that one off. Let's do now 2, 2, 2. So it's going to be 3 times 4 plus 6 times 4 plus 9 times 4. That's not but greater than 100. It's definitely not going to equal 222. 1, 2, 3. Okay, it's got to like be a bit more careful now. So I've got to remember C is the last one. So it's going to be 3 times 3 cubed, which is 27. And then it's the A, so it's 6 times 1 plus 9 times 4. That's going to equal 81 plus 6 plus 36, which is 87 plus 36, which actually is going to give 123. All right, so we found a solution. Okay, got to be pretty happy with that. Are there any more though? So 132, 3 times 4 plus 6 times 1 plus 9 times 27. That's immediately going to be like bigger than 180, so that one's no. 213, 3 times 27, 6 times 4, 9 times 1. Okay, that's not going to be big enough. And we carry on. I'm gonna actually at this point it's gonna spoilers. There's not going to be another solution, but I'm just going to carry on writing them down, even though you wouldn't know this until you've checked them all. Okay, because that one becomes 243, so that's not equal. So I'd already written it. 312. Um, I just put a cross by 312 when I did it. I'm trying to realize why. Yeah, there's no way. Like the largest one comes from the 9 times. Well, we're just not going to get a number anywhere near big enough. So I'm just going to put a cross. Because the C part is going to be 1 here with the 9. And then, yeah, we're going to be doing 3 to the 3 at some point, but it's just not large enough. And nor is 321. You can sort of see at this point, yeah, they're going to fail. 222 also doesn't work. And you can check that if you want, and 333 doesn't either. So I think I'm good with this. Like do be thorough during it because you never know. But actually, 123 is the only answer. So I've got to say, I'm a big fan of this question. I thought like it's a really nice start. Um, not too bad to get these numbers, and then B is a good little sort of hint on this Olympiad problem. And this pretty complicated equation with a bit of thought. I'm not saying it's easy to link it together. With a bit of thought, you can see how you can use part one to also find conditions for A and C. Reject the 4 for, I've forgotten which one it was, for C. either early on if possible. Later on is going to be a bit more effort if you're then writing down digits, which is what I did to start with, and then realize actually A, B, and C can only equal 1, 2, or 3. We've already done the groundwork, so just check them and see that the solution is 123. Okay, great question.